So we would like to solve the following very simple problem, but it's actually quite interesting and useful. We would like to determine x and y, the numbers x and y, so that the vector 1, x, y is parallel to the vector 2, -6, 10, 2, -6, -10. I'm sorry, 2, -6, 10. So the idea here and what we should use is a very simple but, as I just said, very useful fact that two non-zero vectors u and v are parallel if and only if one is a scalar multiple of the other. In other words, if and only if there exists a real number lambda, so that u is equal to lambda v. And of course, since we said that they're non-zero, v will also be equal to 1 over lambda times u. So with this in mind, how do we solve this problem? So since we want the two vectors to be parallel, that means that 2, -6, 10 should be equal to lambda times 1, x, y. It should also be possible to solve this without using such a formulaic method, but this will do. So this translates to what? It translates to 2 should be equal, oops, sorry about this. It translates to 2 that should be equal to lambda. -6 should be equal to lambda times x, and 10 should be equal to lambda times y. And of course, I'm saying this because once you multiply or you scale the vector 1xy by lambda, you will find lambda, lambda x, and lambda y. So, of course, once you know that lambda is equal to 2, that implies that -6 is equal to 2x, which implies that x is equal to -3, and 10 will be equal to 2y, which implies that y is equal to 5. So we have that x is equal to -3, y is equal to 5. Again, this is a very, very simple problem. However, what it illustrates is this very interesting thing. So two vectors, two non-zero vectors are parallel if and only if one is a scalar multiple of the other. Somebody here might ask, what happens if one of the vectors is the zero vector? Well, the zero vector is actually parallel to any vector. Now, you can always write the zero vector as a scalar multiple of any vector, but you cannot do it the other way around. So you cannot write a non-zero vector as a scalar multiple of the zero vector. That's why you want both vectors to be non-zero. Thanks for watching.